Hello guys, this is prime concept. So we'll still move further with the explanation of basic electricity. Now we explained and we were able to illustrate a circuit in our last video. Now this is what we got in our last video. We arrived at this circuit with a battery. This is what we got. So this is our resistance and this is our EMF, the battery voltage. Now I want to explain this very briefly, but if you check my previous videos, I've taken time to explain voltage, resistance and current in my previous video. But let me do a quick explanation here so that we can continue building on this concept. Now if you go to the market and say you bought a battery and this is your battery you bought from the market, and they told you that battery you're buying from the market, a dry cell, so the battery you're buying from the market, they told you is 1.5 volts. Now if you bring this battery and you want to confirm if what they told you is actually true, one of the things you will do to confirm is to measure that voltage there to know if it is actually what they have told you. Which instrument do we use to measure that voltage? I mentioned it earlier. The instrument you can use to measure voltage is what you call a voltmeter. So in order to confirm that this value is true, you bring your voltmeter. You connect your voltmeter like this across. You connect your voltmeter. This is your voltmeter. When you connect this voltmeter to the ends of this battery, this is going to give you, in an ideal case, it's going to give you 1.5 in an ideal case. So what it means is that this 1.5 you have gotten is what you call the EMF of the battery. That is the EMF of the battery, because this battery is just there. It's not doing any work. You didn't connect it to a bulb. You didn't connect it to anything. It's not doing any work. So when you measure it, what you have is the EMF. It will give you the same thing that is written on it, the EMF. Remember, in an ideal case, it should give you the same thing because this is not connected to a bulb or anything, so it's not doing any work. Now, what do we define EMF? Because EMF is denoted by the symbol E. So how do we define EMF? EMF is the voltage across the terminals of the battery. The voltage across the terminals of the battery when that battery is not supplying current to an external circuit. The voltage across the terminals of the battery when that battery is not connected to a load, when it's not connected to a bulb, then that voltage you get across the terminal is what you call EMF. EMF for short. EMF simply means electromotive force. So EMF is the voltage across the terminals of the battery when that battery is not connected to an external load. So that is EMF. Now we still have what you call voltage drop. That is different. Now if I come to this place, you would notice that in this case now, this battery is now connected to a load, say a bulb. This might be a bulb. So this battery is now connected to a bulb. Now if I decide to measure this voltage in this state now, connecting my voltmeter to measure this voltage under this condition, what you now get here is no longer the EMF. The reason is because this EMF is now, or this battery is now connected to an external load. There will be a reduction. This thing will be reducing the value of this. So what you now get now is what we call voltage drop. Voltage drop. So this is what you will get, no longer the EMF. So what is voltage drop? Voltage drop is the voltage across the terminals of the battery when that battery is connected to an external load. Voltage drop is the voltage across the terminal of a battery when the battery is now connected to where? To an external load. Or you can simply say that voltage drop is the product of that external load and the current flowing through it. Voltage drop is the product of the external load, that is the resistance, and the current flowing through it. So the symbol for voltage drop is V. The symbol for EMF is E. The symbol for voltage drop is what? V. And what is the formula for V? V is simply the current times the resistance. So V is IR. So V equals IR is called voltage drop, while E is called what? EMF. So these are some of the things you need to also understand so we can proceed. Now let's move further. Let's move further. Since we understand what voltage drop is, we understand what EMF is. The next thing we want to look at, because you will not be getting simple circuits like this, the next thing we want to understand is Ohm's law. Because for all the circuits, we will need to always apply Ohm's law at the end to be able to determine either the voltage or the current flowing through the circuit. Now, what is Ohm's law? Ohm's law has a mathematical relationship, but I would first state Ohm's law before I give the mathematical relationship. What is Ohm's law? Ohm's law simply says that the current flowing through a metallic conductor, the current flowing through any metallic conductor is proportional to the potential difference across the terminals of that wire. The current flowing through a metallic conductor is proportional to the potential difference across the terminals or ends of that conductor, provided that temperature and other physical constraints are kept constant. So what do we mean by that? We simply mean that if if you want a certain amount of current to flow through a wire, you have to determine the amount of current that will flow by the voltage or the potential difference that is applied across the end of that wire. I earlier mentioned or explained in my previous videos that potential difference or voltage is that electrical quantity that forces current to flow. So it means that if you want a large amount of current to flow, you have to increase the potential difference so that it can force large amount of current to flow. And that is what Ohms was trying to explain in his law, telling us that the current that would flow through any conductor is going to be dependent on the potential difference that you are applying across its end, as long as temperature is constant, because temperature can influence that. So once you keep temperature constant, then this law is going to apply. All right. Now, what is the mathematical relationship for Ohm's law? Ohm's law is simply given as V equals IR. So this is Ohm's law. V equals IR. Now, for every circuit you will be dealing with, one of the things you would need to achieve is to be able to reduce every circuit so that you can directly apply Ohm's law to it. Now, you can have a circuit where you have more than one resistance. So what do you need to do there? You would need to reduce those resistance. If you have 3 resistors, you want to compress them to get one. That single resistance that would have the same effect as maybe 2, 3 or more resistors, that single resistance is what we call equivalent resistance. So for every circuit that has so many resistance, you would want to learn how to reduce them to get one, which is known as the equivalent resistance. So the next thing I want to explain is how do we get equivalent resistance in a circuit where we have so many of them. Now, in circuit arrangement, we can have these resistors arranged in different ways. In circuit, there are 2 major ways that resistors can be arranged in circuit. One major arrangement you can have for resistors is what we call series arrangement. So we can have series arrangement for resistors, right? And then another arrangement we can have is parallel arrangement for resistors. So these are the 2 major arrangements we can have for resistors. And then you can still have a combination of series and parallel. But if you understand series and then you understand parallel, when you see a combination, you'll be able to analyze the concept behind it. Now let's see what series arrangement actually is. Resistors are said to be arranged in series when they are connected head to tail. When they are connected head to tail, I usually use that to explain. So when you see resistors lined up, one head to the other tail, one head to the other tail, then automatically that arrangement is a series arrangement. Now say we have one resistor like this, and this is the head of this resistor, and this is the tail of this resistor. Now we have another resistor like this, and this is the head of this resistor, and this is the tail of this resistor. If I join the head of this to the tail of this, automatically what I have here is a series arrangement. Now, how else can you know that an arrangement is series? It's very simple. Assuming that this is a straight pipe that can carry water, if I push water through this end, can the water that flows through this also flow through this? That is what you check. If the same water that flows through this would flow through this without deviating, it simply means that these two resistors are connected in series, right? So no matter how the arrangement is, it might be bent. Say you can have something like this now, can have it like this, then you have like this. So in this case now, some persons might be confused. Say, this one does no longer look like series arrangement. But watch, assuming this is a pipe that can carry water, if you pour water here, you notice the water would flow, get to this point. There's no other place that water can go to still come. The same quantity of water will still come and flow through this. Then automatically, this is still a series arrangement. But if there is a deviation, say somebody now decide to connect something here, if you force water to flow through this place and the water flows, when it gets to this point, definitely some of the water will go through this place, another quantity of that water will go through this place. So in this situation where the water will split, this is no longer a series arrangement. So it is only a series arrangement when the same water flows without deviating, without splitting. So this is not series. But if I remove this other terminal, you notice that the water that flows through this would flow through this. So this is a series arrangement. This is a series arrangement. So whenever you see a lot of resistors, just try to use this illustration to find out if the same quantity of water would flow. When you get to a point where the water would have to split, you should know that from that point where the water would split is no longer series arrangement. All right? Now let's look. If we have established that these resistors are arranged in series, we can have more. Let me add more. So we have 3. So we have R1, we have R2, and we have R3. So we have 3. We can have 4, 5, and so on. Now say we have 3 resistors, and we want to find the equivalent resistance. What do we mean by equivalent resistance? Equivalent resistance is a single resistance that will have the same effect as these 3 resistance put together. So why do we always need to find equivalent resistance? Is because whenever you have a circuit, you want to always reduce that circuit so you can apply Ohm's law. Ohm's law is only applied to one current and one resistance. So if you have so many resistance, you want to combine them to get only one. And that single resistance is what you call equivalent or effective resistance. So if you have resistors arranged in series, how do you get the equivalent resistance? So for series arrangement, the equivalent resistance, which you usually write like this, is going to be their sum. So you just add them up directly. So it's going to be R1 plus R2 plus R3, and so on. If you have more, you keep adding. So when you have resistors in series, you just add them up directly and you get the equivalent resistance. I'll take a simple example here to clarify this. So say we have this, connected to a battery source. So we have something like this, and this is 2 ohms, 3 ohms, 4 ohms. So this is, let's say, 3 volts, even if we don't have something there now. Say we have this, and they say find the equivalent resistance. Find the equivalent resistance. Since these 3 resistors are connected in series, the simple thing to do is to simply add them. I hope looking at this you know, because if water starts flowing from here, it would flow without any deviation, flow through this. The same water would flow through this. the same water will flow through this. So obviously these three resistors are in series. So our equivalent resistance is going to be R1 plus R2 plus R3. So which is going to be 2 plus 3 plus 4. This is 5 plus 4. This is 9 ohms. So this becomes our equivalent resistance when you have series arrangement. Now, what is the other thing we need to know about series arrangement for resistors? It's very important you note this. Now, when you have series arrangement for resistors, two things you need to consider. Number one point you need to note is that for series arrangement, voltage across each resistor is different. If you have two resistors arranged in series, the voltage for each of those resistors is going to be different, except that the values of those resistors are the same. So you should note, for series arrangement, voltage is different, but the current in each resistor is the same. Voltage is different. Voltage is different. While current is the same. For series arrangement, voltage is different, current is the same. What do I mean by that? Still, we have a circuit like this. We have this. So this is 3 volts, this is 2 ohms, this is 4 ohms. So what it means is that the voltage you have in these 2 ohms, you can call it V1. It will not be the same as the voltage you have here, which you can call V2. So the voltage in each of these resistors will differ. So automatically, looking at this, V1 plus V2 is going to give us 3 volts. So the voltage in each of them is different because both of them are arranged in series. But the current you will have in this place is the same current you would have in this place. Why? Current is just like water. So assuming this current is water, it will just flow through this, come out from here, flow through this. So the current is just like water. So for series arrangement, the current is the same. The voltage is different. So these two concepts are too important in guiding us in solving of problems. So let me run this. So the next thing we want to learn is parallel arrangement of resistors. Parallel arrangement. Now, how do you know that resistors are connected in parallel? Resistors are connected in parallel if their heads are connected together and then their tails are connected together. So you have a parallel arrangement if the heads are connected together and the tails are also connected together. Now, what do I mean by that? So we have a resistor, say this is the head and this is the tail. I have another resistor, say this is the head and this is the tail. Say I have another one, this is the head and this is the tail. So if I have, say, 3 resistors like this, and then I decide to connect all the heads together and also connect all the tails together. The moment you do this, these resistors automatically are arranged in parallel. They are arranged in parallel because their heads are together and then their tails are together. So this is an example of a parallel arrangement. So this, say this is R1 and this one is R2 and this one is R3. Now, how do we get the equivalent resistance in this case? Now, if you have resistors connected in parallel, the equivalent resistance is simply going to be 1 over R equivalent equals 1 over the first one, R1, plus 1 over R2, plus 1 over R3. So depending on how many you have. So you simply do 1 over 1 over 1 over. So this is how you get the equivalent resistance for parallel arrangement. All right. Now I'll be solving this and later I'll still be giving you short ways of solving problems like this. Now let's take a simple example here that will help us understand this. Now, say we have a circuit like this. We have a circuit like this. So, say we have 2 ohms here, and then we have 4 ohms here. I want to find the equivalent resistance for this arrangement. So what will I do? I know that this is parallel because this place will be connected to a battery, so they are both in parallel. And what will I do? I would say 1 over R equivalent equals 1 over R1, which is going to be 2, plus 1 over R2, which is going to be 4. So I have R equivalent is going to be, what is the LCM? The LCM is going to be 4. So 2 in 4 is 2. 2 times 1 is 2. Plus 4 in 4 is 1. 1 times 1 is 1. So I have 1 over R equivalent equals 3 over 4. This is not our answer. Some students might make mistake and stop here. And of course, you would see 3 over 4 in your option and you begin to celebrate. But this is not your answer. So how do we get R equivalent? Let me still go a simple way. What will I do here? I will cross multiply. So I would say 3 times R equivalent. So it's going to be 3R equivalent. And then I will say 4 times 1 is going to be 4. Right? I'm looking for R equivalent. So R equivalent is going to be 4 divided by 3. So this is my answer. So my R equivalent is 4 divided by 3. So this is how you can solve this. Now, I'll still show you a simple way of solving this. Now, assuming this method I want to explain now would easily work. We can apply it more, but it would easily work when you have only 2 resistors. Now, say I don't want to solve this method. I don't want to waste my time under exam condition. I have only 2 resistors, then automatically my R equivalent is going to be their product. It's going to be their product over their sum. So this is the formula you can use when you have only 2 of them. It's going to be their product over their sum. So what is the product? It's going to be 2 times 4. 2 times 4. What is their sum? It's going to be 2 plus 4. 2 plus 4. So I have 2 times 4 is 8. 2 plus 4 is 6. So when you reduce this is going to give you 4 by 3 ohms. So, which is same answer we got in this case. So you can see how simple and very fast that method is. So this is how you can get equivalent resistance for series and for parallel arrangement. I will give one more example. And let's say we have a complex circuit and we want to find the equivalent resistance. Say we have a circuit that looks more complex but is simple. Now say we have something like this. So we have something like this. So this is 1 ohm, 2 ohm, 2 ohm, 1. So say this is what we have. Now if you look at this, the question says find R equivalent. Now if you look at this, you will notice that this is a combination of both series and parallel. Now when you have arrangements like this, don't be scared. One of the things you look out for is where the part that looks more complex, start tackling from that side, right? And if you check this, you don't start saying, okay, this one, is it arranged in series or arranged in parallel? Ignore this. If you look at this, you see that this one is in parallel. So this is a parallel arrangement. This is clearly a parallel arrangement. Now, if you resolve this, you can resolve these two to get 1, and then you redraw the circuit. You see how simple it becomes. Now, if I resolve these two, I would have my first equivalence, R equivalent 1 for this. Using the short approach is going to be the product, that is to say 2 times 2, right? So 2 times 2 is 4 over their sum. 2 plus 2 is 4. So the first equivalent is what? 1 ohm, right? Now, if I redraw this circuit, remember these two have now become 1. If I redraw this circuit, I would have something like this. This is going to be my A, then this is my 1 ohm. Then these two, I'll draw it as 1, which is now this, and it has a value of 1 ohm, connected to this part again, which is also 1 ohm, and this is your point B. If you look at this now, this is very simple. So you have these 3 resistors arranged in what now? In series. So how do we solve this? Should I leave it for you to solve? Anyway, let me finish it up. Now we have 1 ohm, 1 ohm, 1 ohm. So our final equivalent resistance is going to be 1 plus 1 plus 1. So if you add this up, it's going to give us 3 ohms. So this is how we can solve this. Now I will stop this here so that the video does not become too long. But then I believe in this video I've been able to explain a series of concepts that would still lay foundation for the next video. Try to follow my videos in series and understand the concepts behind all these things. In my next video, I'll be solving more problems under this, and then we'll be looking into another very important circuit analysis, which we call Kirchhoff's circuit law, right? So thanks for watching my video. Please do well to subscribe to my channel, share the videos to your friends so that they can learn. All right, thanks for watching. This is Prime Concepts.